How does quicksand function as a non-Newtonian fluid? Imagine walking across a swampy area and suddenly sinking into the ground. That's because quicksand acts very differently from regular liquids like water. It's a fascinating example of a non-Newtonian fluid, which means its thickness or viscosity changes depending on how much force you apply. And like water, which flows smoothly no matter what, quicksand can behave like a thick gel or a solid, depending on how you move. At rest, quicksand looks like a solid, holding its shape and supporting some weight. This is because the sand particles are suspended in water, creating a gel-like structure. When you step gently on it, the quicksand flows around your foot, making you sink slowly. This happens because the particles separate, and water moves between them, turning the mixture into a more liquid state. It's similar to how a mixture of cornstarch and water, called oobleck, flows easily when pressed lightly but becomes stiff when struck hard. If you suddenly jump or thrash around, the quicksand reacts differently. The rapid movement causes the particles to lock together tightly, increasing the mixture's viscosity. This makes it act more like a solid, resisting your efforts to escape. So, quicksand doesn't just swallow you up instantly. Instead, it responds to your movements, changing from a flowing liquid to a semi-solid mass depending on the stress applied. This behavior is a perfect example of shear thinning non-Newtonian fluids. Shear thinning means that when you apply a gentle force, the fluid becomes less viscous and flows easily. But if you apply a sudden or strong force, it thickens and resists movement. This is why slow, steady movements can help you escape quicksand, while panicked thrashing makes things worse. Understanding quicksand as a non-Newtonian fluid helps explain why it's not as deadly as movies often show. It's all about how the particles and water interact under different stresses. This concept isn't just about quicksand. It's used in designing materials like protective gear that stiffen on impact or paints that resist clumping. So, next time you see quicksand in a movie or read about it, remember it's a bizarre physics and chemistry example of how materials can surprise us with their strange, fluid-like behavior.